about unified modeling language, but then I realized basically nobody knows what it is. It's a way to kind of, like, it's a system of standards to design a system. So before you start implementing and writing all of this different code, kind of drawing out what the different relationships are. But before you can get to that, you have to, kind of start to understand what the requirements are. So you need to talk to stakeholders, people who are interested, who you're doing the project for, who your customer is, who the users are. Customers are not always the users. Sometimes they're a subset. So I figured I'd talk about establishing requirements. And specifically, I wanted to say that requirements are kind of like a progressive understanding of the customer's and users' needs. It's not supposed to be something that you decide on all at once and then stick to. You're going to kind of go about it iteratively, and that's the best way to do it. You don't want to, it's a very high risk way to do it, to say these are the requirements and they're not going to change, because we're humans and it always does change. So in terms of what is a requirement is some sort of statement about what the system, what the application is intended to be, and how it should perform. And the stakeholders are people who are either affected by the system in some way, interact with it in some way, either directly or indirectly, or themselves have an effect on the system. And the goal of establishing requirements is to, get very specific, unambiguous, clear understanding of kind of what the different needs are. And the reason I'm talking about this is because IT projects, software projects have a relatively high failure rate. Different ways to go about doing it include, agile, ad hoc development, lean, traditional, and they all have different success and failure rates, and all do well in some things better than others. But overall, it tends to, be difficult the larger the problem and the application itself gets. It gets more complex. You guys have kind of seen that with your projects, trying to collaborate on GitHub between 4 people versus trying to collaborate with 20 people. It just, it keeps growing and gets more and more complicated. Also, it's good to understand that there are different, people define what a successful or challenged or failed project is in different ways, depending on their viewpoint and what they're looking at. But typically, a failed project is one that doesn't complete. So you start it, you're going to, design this really cool system, and at some point you just scratch the entire thing and say, it's not worth it. It's not worth going any further and putting any more work into it. And as I said, results may vary, but usually, the success or failure of a product depends on the quality of the product itself, the value it has for stakeholders, the return on your investments, and the time and schedule. If something would have been really useful to have and is a great project, but you didn't get it in on time, maybe that's a failure for some people, maybe it's not. But it's just one of the many factors that goes into it. And this is kind of a famous report that came out quite a while back in 2009 that rates, I guess, the different factors of what made a project successful or what made it a failure, and kind of, different people who were involved in those projects' opinions of it. So successful project tends to have high user involvement, support from the executive team, and a clear statement of requirements, which is why I'm talking about it. And things that failed or didn't do so well tended to be because of incomplete requirements. If you don't know what the requirements are when you're trying to build a system, and the more ambiguous they are, the more likely it is to end in failure, and the more high risk it tends to be. So there are different types of requirements. There are functional requirements, which are the most commonly thought of ones, which include, what should the system do? Should your web application let you put things in a cart? And very kind of, the very active and visible ones. And then there are also non-functional requirements. So examples of those are like user experience, performance. If you have a great product, but if the application, if a website takes 10 minutes to load, you're not going to use it, no matter how great it is. So those are those fit in on the non-functional side. And then there are also data requirements. So thinking about what database you're going to use, persistence, the size, the volatility, depending on the project, all of those different things can vary quite a bit. There are also, I guess, a few other types of requirements are the physical environment. So the space you're in, the country you're in. Are you working on a laptop in like a nice air-conditioned room like we are, or do you work in construction and you're exposed to the environments? There's also the social environment to think about. What is the culture? Where is some system going to be used? Where might that application be relevant? How are different people going to communicate with each other? And then there are also the technical requirements. So, are you going to use mean stack? Are you going to use MongoDB and all of that? The other thing you need to think of are user characteristics. So kind of, Nimit talked about this a while back, but kind of trying to understand the characteristics of your users that you're making some IT solution for. What are their needs? Is this a real problem? How do they go about their daily lives? What are their customs? Are you expecting them to use the application like very frequently versus infrequently? Because those have different, user needs. Someone who's a frequent user wants like short, easy ways to do stuff, like key commands, versus someone who's infrequent might want more detailed directions. That goes along with novices versus highly experienced experts. And how they might interact with a different system. Novices might want a more structured environment where experts might want more flexibility. But overall, establishing requirements tends to be fairly difficult, at least difficult to do well. There are a lot of different things that you have to consider. And there's always the people factor. The fact that when you're, going out and trying to talk to different stakeholders, they tend to have a very narrow view of what they want a certain product to do, as compared to, someone who's designing the system who needs to understand in a more broad, more full sense, what the different possibilities for a system might be. So one of the solutions is to develop use cases. Which tend to be like a very narrow view in themselves of how a user might go about interacting with a system. So you kind of you do a run through of this user is going to log onto the site, they're going to create an account, they're going to add something to their shopping cart, and that tends to be something that we can all relate to because I think most of us have participated in e-commerce. But then you also have sellers. And I don't know how many of you in the room have, made a life or like made a living off of selling things online and selling things like off of Amazon, and how those experiences might be very different. So I don't know how many of you have heard of the waterfall process. It tends to have a really bad reputation because the idea is, to have set requirements and then to not budge from those. And ideally, you're supposed to iterate through as this life cycle development goes on and on, but that often doesn't happen. So one solution of that is to kind of have an evolutionary approach. So, to gradually try and understand as you move on, to gradually get a better understanding of what different user requirements are, what a customer's requirements are. What are the requirements of the developers and the technology, and you get a more detailed understanding of that as you move on. So the process of establishing requirements kind of starts with identifying who the key stakeholders are. And these include like customers, systems of people that they would interact with, organizations potentially, people who support the system, people who don't support it. Often stakeholders might have opposing viewpoints or opposing opinions. Let's see. And then I'm just going to show you a quick example of what one might look like. So this is kind of, the system itself is kind of irrelevant, but it's kind of like, you write down who the stakeholder is and what their broad concerns are. So someone might be concerned about ease of use, security, privacy concerns, integration with other technologies. And then that, in turn, gets turned into a feature backlog of things that a user either wants or needs. And from there, you can kind of rank what's most important and start creating a minimal viable product. But I think that's all I have time for. Are there any questions? Yes?
Seems like in a lot of cases requirements would relate directly to tests that you would want to run eventually. Yeah, I guess I don't know what my question is. How much of a correlation do you think that those two things would have?
So part of developing a use case is generally how someone might go about using that. I think that's a good way to develop tests off of. And then there are primary routes. So the A to B versus someone who goes from A to C to D to B and doesn't take the intended route, and kind of needing to take both of those things into account. Yes?
It seems software engineering as a field is not as rigorous or as testing wise, as strong as other engineering fields. Software engineers fail far more often. Our bridge builders fail as often as software engineers did we put bridges ever. So it's
Right.
How can we bring the field of software engineering to a place where we don't fail 30-some odd % of the time and go over budget over time, another 40-50% of the time over that.
Right.
Pure success rate is terrible. In these methods that we've had for a decent amount of time, don't seem to be improving it all that much. We do raise that.
I think part of it is establishing requirements and doing it in a way where the person purchasing the bit, the person paying for the bridge, is also paying for, there tends to be a disconnect between the customer and the user. They're not always the same people. Sometimes they are, but they're not always. And it can get really messy when the customer doesn't understand the needs of the user. Or it's also a problem that software moves much faster. So there's kind of a higher risk rate. But doing a really good job on establishing requirements and being agile, using agile or hybrid methodologies tends to decrease the risk of a project failing. Anyone else? All right. Thank you for listening to me.